Now, let us try to find the domain and range of some basic functions. Here are some examples. I have here 1, 2, 3, 4, 5, 6, 7 examples to show to you to get a general idea about the domain and range of functions. Our function, we have a function, it's a relationship between x and y. For my examples, let's say is our independent variables and y is the dependent variables. So for the first number, y is equal to the square root of x. Now, for a square root, the square root is defined as long as the radicand is not less than 0. So if I write that, this is okay as long as x is lot less than 0 or it's greater than or equal to 0. If you take the square root of a negative number, the square root of any negative number, let's say negative 3, does not exist. Does not exist in our real number line, in our real number system. So, the x values for this function, the x values can only take numbers that are greater than or equal to 0. Now, how about y? If I substitute any number greater than or equal to 0 here, my y value will never be less than 0. It will never be a negative number. No matter how small of x I substitute, y will always be a positive number. That's why y will always be greater than or equal to 0. The smallest that I can substitute here is 0. So the square root of 0 is 0. The square root of 1 is 1. So y goes up no matter what I substitute. Now, this is the domain. All values of x is greater than or equal to 0. And this is loosely defined as the range all values of y. Okay, so this is the domain and this is the range for our first example. For the second example, we have here y is equal to the absolute value of x. I can plug in any real number for x. Any real number given for x. So I can get the absolute value of that. So I say that x is any real number. Again, this statement is my domain. This is the domain. And for y, since this is an absolute value, no matter what I put here, the result will always be a positive number. A positive or equal to 0. So, y should be always greater than or equal to 0. By inspection, it would not be a negative number because this is an absolute value. It tells us that it's either a 0 or a positive. So, this is my range for letter B. For letter C, I have the function y is equal to x squared. So again, x can be any real number. I can square any real number. So x is any real number. And if I try to inspect, y is equal to negative 2 squared. Negative 2 squared is 4. Y is negative 3 squared. I'm just substituting values to see. This is 9. Y equals 5 squared. This is 25. Y equals 0 squared equals 0. All values of my y, all y values, even though if x is a negative number, it yields a positive number. From these substitutions that I did, I can conclude that y is always a positive number. So y is always greater than 0. Now, I substituted 0 and I saw that it can also be equal to 0. So, to make it more complete, my range is y is greater than or equal to 0. Now, for letter D, y is equal to x cube. Again, I can take the cube of any real number. So x can be any real number. That is the domain of my function. Now y, the range, if I cube a negative number, I get a negative number. If I cube a positive number, I get a positive number. If I cube 0, I get 0. So I get all the numbers in the number line. In other words, y is also or can also be any real number. So both my domain and range are the same for letter D. Now for letter E, y is equal to the square root of x minus 1. Now if you go back to our first example, I said that for a square root, the inside of a square root cannot be a negative number. In other words, we have this condition that x minus 1 cannot be negative. So this must be greater than or equal to 0. If I get this in terms of x only, this becomes x is greater than or equal to 1. This is my domain. X is any number greater than or equal to 1. X can be 3, 2, 1.1, 1.5, 10, but it cannot be less than 1. It cannot be 0 because that will yield an impossible square root, a square root of a negative number. So that is not a real number. So here is the answer. X is greater than or equal to 1. That is the domain. Now for the range, I can see that if I substitute 1, I get 0. If I substitute any higher number, I will get a higher number. So y is showing up to be greater than or equal to 0. Any number that is greater than or equal to 0 can appear as y. Now, another example, F. Y is equal to the square root of x squared minus 4. Again, x squared minus 4 must be greater than or equal to 0 for this function to be defined. So if I transpose negative 4, that is x squared must be greater than or equal to 4. Must be greater than or equal to 4. Now, when we what are numbers that are greater than or equal to 4 when squared? I can actually get the square root. I can say that x is greater than or equal to. If I solve for x squared greater than or equal to 4, I can get x is greater than or equal to 2 or x is less than or equal to negative 2. If you realize any negative number less than negative 2, when I square it, the result will be greater than 4. So this is satisfied. So this is my domain. Now for my range, if I satisfy my domain, my range becomes again greater than or equal to 0. So this is my range and this is my domain for letter F. For letter G, example G, y is equal to x minus 2 over x plus 1. Now for a function in this form, we call this a rational function because it's a fraction, it's a ratio. And this one we call this a radical function. It has the radical sign. Now for rational functions, a ratio is defined as long as the denominator is not equal to 0. So x plus 1 must not be equal to 0. And only one value of x will make this equal to 0, and that is negative 1. So x must not be equal to negative 1. So this is my domain that makes sure that the denominator is not equal to 0. And now for my range, if I solve for my range, we need to think about this one. Okay. Now, for the range, one technique is that we solve this for x. So we find out an equation that is in terms of y. We solve this for x. So this becomes x plus 1 times y is equal to x plus minus 2. So, okay. Now let us solve it for x. Xy plus y is equal to x minus 2. And now, let's see. Let's transpose x to the other side and transpose y to the other side. And then let's take out the x. Y minus 1 is equal to negative 2 minus y. So I can see here that x is equal to negative 2 minus y over y minus 1. So this is our function. I'm sorry, let me show that to you. This is our function. In terms of y, we solve it for x. Now, let us see where this is defined. What values for y will it be defined? So, y minus 1 must not be equal to 0. So, in other words, since y minus 1 must not be equal to 0, y should not be equal to 1. This is our range. And our domain, again, is x is not equal to negative 1. This is our range, and this is our domain for the given function. Y is equal to x minus 2 over x plus 1.